Aloha, everybody. Hope you're doing well. Hey, I wanted to have you guys try this new warm up. You notice it's not on blue paper like most of the warm ups. Why is that? Well, I want to use graph paper because I want to teach you something new. Some we'll be doing in the book next week, and you're going to get a little head start on those kids who don't have your integrity and aren't doing the warm ups like they should. So you guys will have an advantage. Because, like I say, if you do the warm up, homework's easy. You do the warm up and the homework, your tests become easy. And it's always sort of a reward for those that work hard, right? So I appreciate you being here, appreciate you trying this out. And I want you to copy these down. If you have graph paper, go ahead and do it. It makes it a little bit easier when you get these area problems. If not, you can do it on binder paper, right? Yeah, you draw it freehand. It's kind of cool to see the boxes though. So go ahead, copy it down, and then come back, and we will go over the answers. All right, aloha. Okay, mahalo, everybody, which means thank you. And let's get these answers, right? What two numbers have a product of 48 and a sum of 14? That's going to be 8 times 6. How about 60 and 19? 60. Where does 60 come in real life? I always think 60 seconds, 60 minutes, right? And a quarter of an hour, fourth of an hour is 15 minutes, and 4 times 15 is 60, and 4 plus 15 is 19. So that works, right? How about 1,000 and 1100s? Yeah. It's easier than you thought, huh? 0.1, 1/10, and 0.01, 100th. A tenth and a hundredth, a dime and a penny makes 11 cents, 1100s. And when I multiply, remember when you multiply, you just say multiply like there's no decimal. 1 times 1 is 1. But here I had to move the decimal over once to pretend that was a 1, and move the decimal over twice over here to pretend that was a 1. That's a total of 3 spots I moved decimals in my problem. So I have to go back 3 spots in my answer, which means I'm filling in 2 eggs there, 0.001, 1/1000. All right. Okay. All right. The other thing I've been teaching my kids is the word of means times, right? So you can use that both ways. It helps you when you have a word problem and the word of's in there to know, hey, I'm going to have to multiply. But you can also work backwards and know that 1/10 times 100th is 1/10 of 100th, right? If you have 100th, it's not much, huh? Like a penny, right? It's 100th of a dollar. You're going to take 1/10 of that. Wow, that's a small piece. It's 1,000. Okay. All right. Did I stump you on the fraction mixed numbers? I have been doing that. I've been known to do that lately. 3 times 2 and 1/2. 3 times 2 is 6, and 3 times a half is 3 halves. So 6 and 3 halves. Now 3 halves is improper, right? That's 1 and 1/2. So I'm going to use that 2 halves to make that another whole. That's 7, and I'll have 1 left, 7.5. And 3 plus 2.5 is 5.5. Okay. All right. Here's where you're going to solve for the value given. X to the third power. Do you remember another way of saying to the third power? It's not squared, to the second power squared. Okay. Now, we haven't talked about this in class, but I've talked about it on warm-ups. You've been doing the warm-up. You know to the third power is cubed. X cubed is how much if X was 2? Well, if X was 2, then I'm going 2 cubed. Now, remember, that's not 6. It's 2 times 2 is 4 times 2 is 8. Okay, so that's going to be 8. And if X cubed and X equals 3, I'm going 3 times 3 times 3. That's 3 times 3 is 9 times 3, 27. 4 cubed, 4 times 4 times 4, that's 16 times 4, 64. Okay. Now, how about 2 to the x? Now I'm saying 2 to the x. If x is 3, that's 2 to the third power. That's 2 times 2 times 2. We figured that out. That's 8. Now, 2 to the fifth power, that's 8 times 2 times 2, right? 8 times 2 is 16, and 16 times 2 is 32. Okay, now what if x was 8? Now that's 2 to the eighth power. Oh my goodness, that's a lot. Now I already figured out x to the fifth. I'm going to use 5 of those and say that's 32. And then I still have to go times 2 times 2 times 2 to get to 8, right? This is 5. So that's 64, right? 64 times 2 is 128. And 128 times 2 is what? Mr. Daniel's favorite number, 256. All right, 128 divided by x. If x was 4, you're doing 4 into 128. And it's a nice even fit for the 12, right? Bring down the next number and a nice even fit there. So 128 over x, if x was 4, would equal 32. If x was 8, 8 into 128, it only goes once, right? Bring down that. And it goes into 48 6 times. That's 16. And 32, we just figured that out, didn't we? Right? 4 times 32 is 128. So 32 goes into 128 4 times. All right. 3.5. I want you to use a generic rectangle on this one. So let's go 3, 1/2, 4, 1/4. 3 times 4 is 12. 3 times 1/4 is 3/4. 4 times 1/2 is 4 halves, which is 2, right? 4 half pieces is 2 pieces. 1/2 times 1/4 is 1/8. So I have 12 and 2 is 14, right? And 3/4 and 1/8. I'm going to go ahead and change that 3/4 to 6/8. Okay, so I got 7/8, and again, the 12 and the 2 makes 14. Okay, 18 and 3 2/9. 18, 3 2/9. 3 times 18 is 54. 18 times 2/9 is 18 times 2 is 36 over 9, and 9 goes into 36 4 times. So this ends up being 58. 58. Okay. Now, the area of a rectangle, you just multiply how wide it is times how tall it is. 4 times 6 is 24 square units. If you counted each one of these little squares, you get 24. 2 times 4 is 2 rows of 4. 1, 2, 3, 4, 5, 6, 7, 8. Now, check this out. The area of a parallelogram equals the width times the height. The width is how wide it is, and the height is how tall it is. Okay? Now, how tall it is straight up and down, right? You got to make sure you don't measure yourself with a ruler going at an angle. It's got to go straight up and down. So check this out. Why does this work? Okay. Well, a parallelogram, that means this line and this line, if they went forever, they would never touch or get farther apart. That's what parallel means. Those lines are parallel. Opposite sides are parallel. Both of these lines are horizontal. If that line went forever, that line went forever, they would never touch or get farther apart. That's what parallel means. So this angle is the same as this angle. And if I were to chop off this part of the parallelogram, I could slide it over here and put it right in here. And then what shape would I have made? A rectangle. That's 4 tall, that's 6 wide. So that is 24 square units. Cool, huh? Okay, this one. If I were to chop off this and move it over here, it would fit perfectly in there because this is a parallelogram. So 4 times 2 is 8. How wide it is times how tall it is. I wanted to show you that I can make this shape if I cut this off, put it over here. I can make this shape if I cut this off, stuck it over here. Okay, so it shows you why a parallelogram is just how wide it is times how tall it is. Okay, here's one that's 4 wide and 3 tall. What's going to be the area? 4 times 3, 12. Now, I can see that if I chop this off and slide it over here. Now I have this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same idea here. What's going to be the area here? How wide is it? 5. How tall is it? 3. Now, they're going to give you problems where they give you a value of this number too. Say that's 4, right? And people will get confused, and you want to multiply all three of them, but don't multiply all three. You need to know for the area of a parallelogram, how wide is it times how tall. That's all you got to do. Now, if you were getting perimeter, you would need that 4. You're building a fence around this shape, and you wouldn't need the 3 for the perimeter, right? That's not really, that's just how tall it is, right? It's not, it's, it's the same as this, right? That is also 3 right here. You don't care about that for the perimeter. For the area, you do. It's 3 wide, right? If I slid that over here, I made a rectangle, and that's 5 times 3, 15. And then again, area is always square units. All right, that's a little taste test for something that's coming your way. Hopefully it wasn't too confusing. But yeah, and this is something you'll memorize, area of a parallelogram. And usually what I do when I write these area formulas, I draw the shape, and I don't put a box around it. I put a parallelogram around it, right? And when we do triangles, I'll do the same thing. Okay. All right. Have a good day, everybody. Aloha. Thursday. Wow. Thursday already.